Have you ever stopped and wondered what's really going on inside an AI's brain? I mean, we throw around terms like machine learning and neural networks all the time, but how does an AI actually, reason? How does it connect the dots? Well, today we're going to peel back the layers and look at the fundamental logic that actually powers artificial intelligence. Okay, quick question for you. The cricket ground is wet. What's the first thing that pops into your mind? I bet you immediately thought it must have rained, right? You didn't have to pull out a calculator or run a complex analysis. Your brain just knew.
That little mental leap you just took, that was an incredibly sophisticated expert guess, all based on a lifetime of experience. And honestly, that's the core challenge in AI. How do we teach a machine to make those same kinds of smart, intuitive leaps? So let's explore exactly how it's done. To even get started, an AI needs a basic toolkit for thinking. So I want you to think of these as 3 different logical detectives, and each one has its own unique style for cracking a case. Let's meet the first one. First up, we have deductive reasoning. This is the Sherlock Holmes of logic, no doubt about it. It starts with a big, general rule that we know is true, and then it applies that rule to a specific situation. It's all very top-down, and here's the key. If your starting facts are solid, the conclusion is 100% guaranteed. So let's look at a super simple example. Let's say our first rule, our premise, is all humans eat veggies. And our second fact is Suresh is human. Well, the conclusion is totally unavoidable. Suresh eats veggies. It's a logical certainty. See how it flows directly from those first 2 statements? Okay, so our next detective is inductive reasoning. And this one works in the complete opposite way. It's all bottom up. It takes a bunch of specific individual observations and then tries to create a broad general rule based on that pattern. For example, if every single pigeon you've seen at the zoo happens to be white, you might conclude, therefore, all the pigeons at the zoo must be white. But is that conclusion a sure thing? Absolutely not. There could easily be a gray one hiding just around the corner. It's a probable guess, not a guarantee.
And seeing them side by side like this makes it crystal clear. Deductive, top-down, starting with a big rule to get to a guaranteed specific conclusion. Inductive, bottom-up, starting with small observations to create a probable big rule. This difference is so important for understanding how an AI can both follow strict instructions and make educated guesses about the world. Which brings us to our third and final detective, abductive reasoning. This is basically the logic of finding the most likely explanation for something you've observed. Hey, remember the wet cricket ground? You used abductive reasoning. You saw an effect, the wet ground, and you came up with the most probable cause, rain. It's the logic of making the best possible guess. Okay, so we've met our 3 logical detectives, but let's be real, the world isn't neat and tidy. It's messy, things are always changing, and new information pops up all the time. So an AI needs a way to deal with all that uncertainty. One approach is what we call monotonic reasoning. Now, in this kind of system, once a fact is established as true, it's true forever. Period. You can add new information, sure, but that new info can never, ever contradict or invalidate what's already in the system. The list of facts only gets longer. It never changes. Think about a fact like this. Earth revolves around the sun. That is a classic monotonic fact. You can learn that Jupiter has dozens of moons or that a new comet was discovered. None of that new knowledge is ever going to change the original fact about the Earth and the sun. It's set in stone. But here's the catch. Most of the world doesn't work that way. We make assumptions all the time that can turn out to be totally wrong. What we think is a fact today might get completely overturned tomorrow. So how on earth does an AI handle a world that's constantly in flux? Well, it uses something called non-monotonic reasoning. And this is a much more flexible, much more realistic way of thinking. It actually allows a conclusion to be thrown out if new contradictory information comes along. In other words, it's a system that's designed to change its mind. Let's see this in action. It's pretty cool. We start with 2 basic facts. Birds can fly, and Pitty is a bird. Based on that, the logical conclusion is pretty simple, right? Pitty can fly. But hang on a second. What happens when our AI gets a little data update? What if it learns a new piece of information about our friend Pitty? Boom, here's the update. Pitty is a penguin. That one new fact completely invalidates our old conclusion. So the AI reevaluates everything and comes to a brand new conclusion. Pitty cannot fly. This ability to adapt, to self-correct, is exactly what makes an AI truly useful in our dynamic, ever-changing world.
All right, so we've covered how an AI thinks, but what does it actually think with? I mean, for any of this reasoning to happen, the AI needs a massive library of information to pull from. We call this its knowledge base. And you can see here, an AI's knowledge isn't just one giant messy pile of data. Oh no, it's highly organized. It's structured into different categories, one for basic facts, one for how-to procedures, one for rules of thumb, and even knowledge about its own knowledge. Each part plays a specific role. Let's break this down real quick. Declarative knowledge is just knowing what. Simple facts like Paris is the capital of France. Procedural knowledge is knowing how. Think of it like a recipe, the step-by-step instructions to do something. Then there's meta-knowledge, which is kind of wild. It's knowledge about knowledge itself, like knowing that information from a scientific journal is probably more reliable than a random blog post. Heuristic knowledge is basically rules of thumb, like if the traffic is bad, take the back roads. And finally, structural knowledge is all about understanding relationships, like knowing a square is a type of rectangle. All of these have to work together. Okay, so let's put it all together now. We have these methods of reasoning, our logical detectives, and we have this massive, organized library, the AI's knowledge base. Here's probably the easiest way to think about it. The reasoning part is like the AI's processor. It's the engine that does all the work. But that engine is totally useless without any fuel, right? Well, the knowledge is its memory. It's the fuel that the engine needs to run. You absolutely, positively cannot have one without the other. And that brings us to the really big idea here. We are getting incredibly good at building systems that can reason through problems with flawless logic, and they can access more knowledge than any human ever could. But that leaves us with a much bigger question. We're getting really good at teaching AI to be logical, but what's it going to take to teach it wisdom,